స్టార్ట్ చేయండి మేడం, స్టార్ట్ చేయండి.
Okay. Good afternoon, students. In the previous classes, we have discussed least distance of distinct vision. What is the value? The value is 25 centimeter. And in the activity 2, we learned that the angle of vision is 60 degrees. Okay, if the vision angle is above 60 degrees, we can't see the top and bottom of the object. For suppose we hold a pen in front of our eyes, it is very closer to our eye, we can't see the top and bottom of the pen. Is it right? Did you observe? So the angle of vision is 60 degrees. And next one, we have discussed the structure of human eye in the previous class. See the figure. What we have discussed, the components are ciliary muscles, iris, pupil, aqueous humor, lens, retina, and optic nerve in this figure. Okay, so first thing, it is sharply curved surface. It's look like in spherical shape. And what is the work of pupil? It in low light condition, it expands the iris to don't enter the light into our eye. In excess of light condition, it stops the excess light enter into our eye. It contrasts the iris. So it is called as various aperture. Okay. So pupil appears as black because of there is no light reflection. It observes the total light enter into that pot. So that pupil is in black color. Iris is act as variable aperture. And you observe the lens. In our eye we have lens. Okay. The distance between lens and retina is about 2.5 centimeter. This retina it is working for image formation. Okay, so retina works as a screen. In the previous chapter, we have discussed, you have learned the image formed on the screen. So in our eye, any image formed on the retina. So retina works as screen in our eye. Any object, image of any object will be formed on the retina. So in the figure, we observe that the distance between lens and retina is about 2.5 centimeters. So for any in front of our eye, the image distance is fixed about 2.5 centimeters. So how can we change? Yesterday we have discussed which component is used for adjustment of focal length. Do you know what it is? Ciliary muscles. Okay. So we need to change the focal length for image formation. It's depend on radii of curvature. Okay. Focal length is half of the radii of curvature. So we have to adjust the focal length for image formation. In our eye, ciliary muscles are used to adjust the focal length. So this adjustment of focal length is called as accommodation. So then when we hold any object, is in the distance of, for suppose it is above 25 centimeter, we don't get any strain. So our muscles, ciliary muscles are relaxed. So we can see the object as clear and without any strain. For suppose it is any object is very closer to our eye, we get strain. Ciliary muscles are strained. Okay. So now the does islands form a real image or virtual image? We have some idea about real image and virtual image in the previous chapter. Okay, so as same as here, our islands, is it form a real image or virtual image? And how does the image formed on retina to perceive the object without change its shape and color? All these questions are raised to us. So to answer these, we have to discuss in the continuation of previous class. The eye lens forms a real and inverted image of an object on the retina. You know that, okay? Because we can see only the real images. Understand? When virtual image is formed, we can't see the virtual image because we can't catch on the screen. This knowledge we have in the previous chapter. Okay. So with our eye we can see any object. So that's why it must be a real image. Understand? So the real and inverted image of object is image formed on the retina. So then we can see the object. The retina is a delicate membrane which contains about 125 million receptors called rods and cones. In the figure, you observe the retina. So the retina has rods and cones. What is the work of rod and cones? They receive the signals and transport to the brain. So these signals are transmitted to the brain through about 1 million optic nerve fibers. The any signals from here, then they are transmitted to brain through the optic nerve fibers. Okay, we know that fibers. What is the work of fiber? They transmit the signals. Here is also rods, the signals from rods and cones. The optic nerve fibers transmit to the brain. The brain interprets these signals and finally process the information so that we perceive the object in terms of its shape, size and color. So what it means? When rods receive the signal, then it transmitted to the brain. Then we can find it. Suppose any object is in a round shape. So when we receive the signal from rods and cones through the fibers, our brain identify that, then we can identify the shape, color of the object. Okay, here it is. Eye lens, ciliary muscles adjust the focal length. So how can we find them? So some focal length is used for visible. The limited focal length is helps to see any object for our eye. So what is the focal length used for our vision? We have to know that. Understand? We have to find out the minimum focal length and maximum focal length of our eye. Then based on focal length, we can see the objects because the lens has must work based on focal length. Here it is, and figure is there related to our eye. Here it is, eye is there and this one is retina and the light rays. So apply the knowledge of image formation through the knowledge of previous chapter. Apply the knowledge of previous chapter here. And what is that? When the object is infinity, we know that Where will be the image formed? Yeah, at the focal point. So here it is the parallel rays. Here you observe that parallel rays are there. So these are the object falling on the eye lens are refracted and they form a point-sized image on retina. See in the figure, when object is infinity, the light rays form the image on the retina. So in this situation, eye lens has a maximum focal length. Understand? So we have to apply here when the object is at infinity. U. What is U? U learned in the previous chapter. U is the object distance. Okay. V is the image distance. These both are the distances of object and image. And here it is U observe. U is equal to minus infinity. Why they are taken minus? Anything? Any observation? In the previous chapter, you learned the sign convention for that one. Okay. When we took positive or when we took negative for values. Anything below the principal axis. If any distance below the principal axis, we have taken that value is negative. And above the principal axis, it is positive. So sign convention we have learned in the previous chapter. Just rewind the 3 points of sign convention. So based on that sign convention, we have to use here u is minus infinity. When we measured any distance from the pole, it will be positive. In the previous chapter, another condition is there. If any measurement is from the pole, but when we measure the object distance, we have to do the experiment. Then we measure the value from object to pole. So that's why in the reverse direction, so it will be as negative. So here it is, that is u is equal to minus infinity, v is equal to 2.5 centimeter. We have a length formula, that is 1 by f is equal to 1 by v minus 1 by u. This is also we have learnt in the previous chapter, length formula. So substitute the values of u and v. 1 by f maximum. F means focal length, v is the image distance, and u is the object distance. Here it is 1 by f maximum is equal to 1 by 2.5 plus 1 by infinity. What is the 2.5? Why we are taken 2.5? Because the distance between lens and retina is 2.5 centimeter in our eye. So that's why we have taken B is 2.5 centimeter. And here it is u is minus infinity. So already in the formula 1 by v minus 1 by u is there. So minus into minus, it will be plus 1 by 2.5 plus 1 by infinity. Something by infinity is 0. So that's 1 by 2.5 plus 0. That means reciprocal of 1 by f maximum is f maximum. So based on the f maximum is equal to 2.5 centimeter. So we got what is that? F maximum is equal to 2.5 centimeter. Means maximum focal length is 2.5 centimeter, which is related to understand, that is the maximum focal length. Also we have to find out minimum focal length. So observe the figure, and the next thing here is minimum. The object is placed at a distance of 25 centimeter from our eye. Why we are taken 25 centimeter? Because the least distance of distinct vision is 25 centimeter. Understand? So that's why we have taken 25 centimeter. So here u is equal to minus 25 centimeter. V is as same in the previous situation. There is no change because the distance between lens and retina is 2.5 centimeter. So understand why we taken u is 25 centimeter? Because the least distance of distinct vision is 25 centimeters. So that's why we are taken u is equal 25 centimeter. V is equal to 2.5 centimeter. Using of the formula, lens formula, 1 by f is equal to 1 by v minus 1 by u. So substitute the above values. Here it is minimum focal length. So that's why 1 by f minimum is equal to 1 by 2.5 plus 1 by 25. So after solving this, minimum focal length f minimum is equal to 11 by 25 and minimum focal length f minimum is equal to reciprocal of the above 25 by 11. After the simplification, 2.27 centimeter. This is the minimum focal length. Understand? Compare both of them. Here it is. First one maximum focal length and the second one minimum focal length. When we take maximum focal length, the image distance V is as 2.5 centimeter, U is infinity. When we go for minimum focal length, U is 25 centimeter, V is 2.5 centimeter. So after the simplification, we got the values. What is that? Minimum focal length is 2.5 centimeter, sorry 2.27 centimeter. Maximum focal length is 2.5 centimeter. Observe the two values. So what is the meaning? The focal length is between 2.27 and 2.5 centimeter to see the object. For every human being, the focal length is between 2.27 centimeter and 2.5 centimeter. So the ability of eyelens to change its focal length is called accommodation. This sentence we have learned this accommodation by what it is ciliary muscles. What happens if the eye lens is not able to adjust its focal length? What happens if the focal length of eye lens is beyond the range of 2.5 centimeter to 2.27 centimeter? Some people have some problems. So here it is. Minimum focal length for human being is 2.27 centimeter. For some people, it will be changed. Then what is the problem? We have to find out. For the people, the eye lens can't adjust the focal length. So sometimes the eye may gradually lose its ability for accommodation. In such conditions, the persons can't see an object clearly. So that is called defect of vision. Understand? When the focal length is differ from 2.27 and maximum focal length 2.5 centimeter, then defects are there. So based on the focal length, three types of defects of vision are there. What are the three common defects? Myopia, hypermetropia, and third one is presbyopia. Then for adult people, there is no change. The focal length is between 2.7 and 2.5 centimeter. Minimum focal length is 2.27 centimeter and maximum focal length is 2.5 centimeter. Healthy human being. But some people, the focal length has changed their lens in their eye. So that is called defect of vision. We see the three common defects of vision in the people. The three are: one is myopia, one is metropia, and third one is presbyopia. Now we are going to discuss myopia. Okay, here it is. Myopia, it's a defect of vision which is dependent on maximum focal length. Understand? We have two values: maximum focal length, minimum focal length. So here it is the first one, myopia. It's dependent maximum focal length. Some people cannot see the objects at long distances. They can see nearby objects clearly. We also, in general, in our daily life, so many people say that. Is it right? We can't see the distant objects. Okay, somebody, anybody is there, you observe that. What is the problem here? It is this type of defect in vision is called myopia. Which type it is? Which have myopia disease, they can see the nearby objects, but they can't see the objects at the long distances. This is also called nearsightedness. Understand? One word, nearsightedness. You observe this word, and this word, the above sentence reflects nearsightedness means they can see nearby objects. So, what is the problem? Why they can't see the distant objects? For that people, means who has myopia disease. For that people, the maximum focal length is less than 2.5 centimeter. Understand? Actually, for healthy human beings, maximum focal length is 2.5 centimeter. But for some people, the maximum focal length is less than 2.5 centimeter. So that people can't see the distant object. That defect is called as myopia. In such cases, the rays coming from distant object don't reflect there after refraction through the eye lens, form an image before the retina. Actually, what it is, any object we can see that the image will form on the retina for all the people. When the image is formed the retina, then only we can see any object. If no image formation on the retina in our eye, we can't see the object. So this retina works as screen our eye. For who has myopia defect? For people, the image will form before the retina. You observe the first figure. Here it is. This intersecting point of this light rays is here in front of retina. So that's why before the retina, the image has formed for myopia people. So then a healthy person can see objects at all distance more than 25 centimeter. But with myopia, person with myopia can see objects clearly up to a certain distance. Means, for suppose students, you observe that you hold the book then at the distance of 30 centimeter. If you can see the letters as clear, you don't have any problem. But you observe that some letters are blurred, you have suffered some defect. Understand? The people who suffered with myopia can't see the object distance when it is at the distance greater than 25, means more than 25 centimeter. So extreme point an object appears for myopia people is M. Observe the figure 5C means third figure. You observe the letter M means that is where up to which the place the myopia patient can see, that is indicated with M. L is the least distance of distinct vision, that is 25 centimeter. We know that. So here it is eye lens form an image on the retina in figure 5C, and this M is called as far point. So here it is the point of maximum distance at which the eye lens can form an image on the retina is called far point. The defect in which people cannot see the objects beyond far point is called myopia. Understand what is far point? Maximum distance with eye lens can form the image on retina. So beyond the far point, the myopia people, which has people who have the defect of myopia, can't see the object beyond the far point. If we are a healthy person, we can see beyond the far point also. Understand? So problem is there. Then what can we do to correct myopia? So if any problem is there, automatically one solution is for that problem. Is it right? For everything it has a solution. So what can we do? Correct myopia. The eye lens can form clear image on retina when the object is placed between far point and point of L, means least distance of distinct vision. If we are able to bring the image of object kept beyond far point, then the image acts as a object for the eye lens. Just to see here, here it is, M is a far point, L is the least distance of distinct vision, and for in the first figure you observe for myopia people the image formed before the retina. Understand? Here it is. What we can do? Here it is. First, in the first figure, the image formed before the retina, but if the image form the retina, then only we can see the image. So that's why we have to put this point on the retina. Means it has to extend. Understand? For myopia people, the image formed before the retina, we have to move that image formation on the retina, means we have to expand. Understand? So what we can do, which lens we have used? You have any idea? The previous lesson we have learned different lenses. One means concave lens, convex lens, biconcave lens, biconvex lens. Understand? Can you say, is this biconcave or biconvex? Bi means two. This means biconcave means two sides of lens, it has concave surface. Biconvex means two sides of lens has convex surface. So now, can you say, is this biconcave or biconvex? Okay. Okay, listen here. This can be made possible only when a concave lens is used. Here it is, you observe recollect image formation by refraction through a concave lens from the previous lesson. You know how the image has formed by the concave lens. So what is that? We can use concave lens. Now, can you say which lens it is? Biconcave lens. What happened here? When we put the concave lens in front of our eye, what happened? The image formed on the retina. So for biconcave lens, what happened it is, the image has expanded. Okay, so that's why on the retina. When we put biconcave lens in front of eye of the people who have myopia, the image has formed on the retina. Then they can see the objects. Okay. When we use the lens, biconcave lens for myopia people, then they can see the objects as clear. So to correct one's myopia, we need to select a lens which forms an image at the forepoint for an object at infinity. Means which lens form the image at long distance, the type of lens we choose. So we know that concave lens form the image at the long distance. So that's why we use the biconcave lens for myopia people. So we need to select biconcave lens to achieve this. Then the image formed on retina, then the people can see the object as same as for normal people. Here object distance u is infinity and image distance is equal to distance of forepoint. We have seen in the previous first thing. Is it right? So here it is. U is infinity and V is forepoint, means it indicate with D. Then what is the focal length? We have to measure 1 by F is equal to 1 by V minus 1 by U. We substitute the values of U and V. Then 1 by F is equal to 1 by minus D. Then reciprocal of the above, F is equal to minus D. Here it is, F is negative, showing that it is a concave lens. After you getting the value, minus means concave lens. Okay, here it is. This is the explanation about myopia. Okay, what is that? Myopia means what we have discussed today. Minimum focal length for healthy human being. Minimum focal length of our eye lens is 2.27 centimeter and maximum focal length is 2.5 centimeter for healthy human being. But for some people there is a change of focal length. If suppose the maximum focal length is less than 2.5, the defect is called as myopia. So that the people who suffered with myopia can see only nearby objects. They can't see the distant objects. So for that people, the image formed before the retina. So that's why they can't see the distant object. Then we use the concave lens. When we put the biconcave lens in front of their eye, what happens? The image is formed on the retina. Then the people can see the object. So that's why we correct the myopia disease. This diagram, the first figure is indicates the people suffered with myopia, and this diagram indicates correction of myopia.
Right.
Students, in the exam, the question asked based on the diagram also. They given the first diagram, then what is the question it is? Here it is one diagram they give. Sir?
Okay, madam. Okay, madam.
Oh, sir.
Close, madam. Close.
Sir.
Okay.